Hello, everybody. So tonight's a fun night. The other night we were talking about functions and looking at them in sort of a generic form and random examples, and we do that to see the syntax without a lot of clutter. But it's nice to see an actual example, right? So that's what we're going to be doing tonight. First thing is we're going to look at functions like we saw the other day in C2. So actually in an application. Um, so we'll see it in place and see how those pieces fit together. Those just go a little bit better when we've already seen the syntax. And we got the logic. And for class examples, I usually go with payroll calculators and tip calculators, which we actually make both of them tonight. For the payroll calculator, for the example of functions, most Americans seem to understand how those work really, really well, especially payroll. That's one even people who are terrible at math know how to calculate them, know how to double check their paycheck. So it's a nice, simple logic to put together. We'll see a simple one tonight, and when we get to data structures, we'll also do another payroll calculator. But on that one, we'll be reading probably from a CSV file and pretending like it's an export from a database. A much more realistic situation. It'll be a more realistic sort of payroll. But we can get started with a simple example looking at functions. After that, I want to take our first look at Django. So we'll probably turn around and make that one we will do in an example first. Frameworks are big. Frameworks are the modern way of creating software, and there's a lot to it. So we're just going to talk a little bit along the way throughout the semester and introduce them. Ultimately, it's leading up to your hybrid apps class, which is finally getting developed. That SDEV 257 that has been on the books for like 5 years and everybody's required to take, and it hasn't run anywhere in the state yet. So it will be running soon. But I believe y'all are still a couple prerequisites. So building up to that, modern software development. There's a kind of a steep learning curve on them, so we're going to stretch it out over the semester. There's a tutorial built into the course shell. I use the statewide shell for IE Online, and when that was developed, they decided to go with the comprehensive tutorial, which this is the introduction to it. We don't need the comprehensive tutorial at the introduction level. So what I'm planning on doing is keeping the assignments as they are, but adding to them so that there will be an option of following that comprehensive tutorial or doing something like what we did in class. So if you want to wait till after we cover stuff in class, I'm going to extend those Django assignments. Then I have a general plan for it, but see how far we get in class, and then modifications on your in-class example will work for a homework assignment with that, and then introduce Django instead of trying to fit the comprehensive version in an 8-week class where we're actually studying something else, because it gets a bit overwhelming. We just need introduced to it, and it shows everything, but really we just need the parts that apply to our final projects, right? Just need to know how to make our final project here and how to make a good start on Django, and then we'll be working out all those fine details later. Like after graduation and working as a software developer, and you can work them in on the clock when you're getting paid to learn to work in other details. But we should still get a pretty good start. And for those who have time, I'm not going to delete the comprehensive tutorial. So if you want to go ahead and do the comprehensive tutorial, we'll work through that, and you can still ask me questions about it. But the assignments will be easier after we cover those things in class. Object-oriented programming is also this week, but after we do those two examples, our eyes might be getting tired from staring at the screen, right? So if that gets pushed back, the due date for the object-oriented programming will get pushed back, like we've already seen. So I'm not going to make it due until after we talk about it in class. pretty much those two things. I was expecting it to take a while so that we can clear up some of that things that might have seemed confusing about the functions, especially when it took that big step at the end and went to a very generic thing because there's not a detailed way to do it. And if the prerequisites for this class are the only programming you've seen, that would have been the first sudden sharp turn of going from detailed assignments doing one specific thing into a generalization that works for anything we want to do. That's where we're heading eventually, but we saw the first step the other day when I was getting exhausted. I'm well caffeinated tonight too, by the way. So got caffeine and extra coffee grounds ground in the office so that I can make a pot really quick. But I did make a cup of coffee, so I can also step over to the office and grab something. So hopefully I won't get exhausted exhausted too early this evening like I did the other day. I apologize for that, but it's easier to see in examples anyway, right? So let's jump in here and do an example and kind of look at functions in place, actually doing something with them. I'll start up Spider, which takes forever to start. I probably should have started that before class. Oh, well, that's starting. I'm going to do something. Remember how I accidentally uploaded the wrong thing to GitHub? I accidentally uploaded the folder instead of the files in the folder. I want to delete that. If I tried to delete that from GitHub, while Spider opens, probably a good time to look at this. Again, it's GitHub thing, so preview mode. Right? I don't expect you to know this, because I'm just going to show it to you while we wait for the software to open. If I tried to delete that folder from GitHub, SDEV 220, oops, 220, and we're in this one. So at the end of the night, when I was getting tired, I accidentally uploaded the folder, which instead of the files in the folder. But if I go in here, there's not, you'll notice there's not a little trash can icon like we're used to seeing, or it doesn't seem to be a convenient way to delete that. Let me get the Zoom thumbnails out of the way in here. So on GitHub, you have to go through and delete every single file in that folder. And when all the files have been deleted, then the folder will automatically delete. That's a bit tedious. So if that ever happens to you, what you want to do, let me delete my local copy, delete the copy we've been working with, and then I'll just open PowerShell here. Or on a Mac, the breadcrumbs down at the bottom are how you open terminal from a particular folder in Finder. But open in that directory, and I will make a new clone of the repository. Git clone this repository, github.com, my username, which this is what I do when I grade your homework. The repository is SDEV 220 spring 2024. Git. So this is what I do when I grade your homework. You send me that URL, and then I clone the repository, and then I start running the code and digging through and checking everything. What? I might have got the wrong address, so I'm come over here and just copy it from the green button because I apparently made a typo. Oh, I forgot the 5 in my username, didn't I? Yeah, I forgot the 5 in my username, but git clone and then paste in the copy version. That's a better way to do it anyway. Okay, now we have a new version of that here locally. And as far as folders on the local machine, I have the delete button right here. Gone. So now if I check for the changes, stage the changes. Oh, whoops. We navigate into that folder, change directory to that folder, and now stage the changes. Oops. I need to slow down. Maybe I got too much caffeine tonight. Get, commit, a short message, removed, extra folder. Because that one would have actually caused problems because that was an entire repository loaded into a repository. And it can be done, but it takes extra work. So it's a little funny, extra steps, and not for a class where we're talking about introductory concepts of Git. So we want to avoid nested repositories. And what you do is you just download it and delete the folder. That way you don't have to delete every single file, which you can see that's what it still went through that folder and deleted every file individually. We just don't have a shortcut for that on the website. And then it can push that back to the repository. There we go. And see the folder's there right now. When I reload it, it should be gone. Yeah. So if it's on GitHub on the website, you can delete every single file in that folder and all the subfolders. And when everything else in it has been deleted, then it will automatically be deleted. It's a lot easier just to clone the repository, delete it, push it back up.
So every time we want to add a file from our local repository to GitHub, we need to clone it every time.
I just had to do that because I messed something up.
Whenever you mess it, you need to clone it.
Yeah, whenever you mess something up, clone it back down to do that. But just to upload stuff, yeah, just drag, just however you would do it. Drag and drop here, push it back to the repository. If it's just an addition, it'll note the changes.
If you just want to add, commit, and push.
Yes, just commit and push. On that particular one, that would come with warning messages because that folder I uploaded was a repository. So there was a repository in a repository, which can cause conflicts, and it messes up some of the automated processes. So what I did the other day was a big mistake. If you ever accidentally uploaded an entire repository inside of another repository, a human has to handle that. We lose our automated process, basically. That's when you would want to do what I did, clone it, delete the folder, and put it back up there. Or if at any time you have other reasons to create, you got a folder with 100 files in it, you don't want to sit there and right click and delete every single file, 100 files, right? But download it, delete it all at once, and then push it back up. But yeah, I'm going to go through the steps. Usually it's just commit and push. All right, so now on to our example. Let me close this file. Don't need that. Oh, something I could do. We talked about the guard statement the other day, right? I'm going to put that in every single Python code. So that's a really nice one to put into our template. On Spider, it's under preferences. For those using VS Code, I believe it's under the file menu. That's where Microsoft likes to put them. Somewhere under the file menu, I don't have VS Code installed. Part of the reason for that is so that I'm using a different IDE. Right? We want to switch around, try different IDEs. So I like to make sure I always use a different one than the most popular one right now. Or a different one than what a lot of people in class are using to accentuate that point. But any editor, any text editor or IDE you're using will have a way to edit a template. So on this one, it's under preferences. For those on VS Code, I believe it's under file. I have to dig around for the button. I haven't done it on VS Code in a little while. Probably like a year and a half, maybe longer, maybe even longer. But it's there is a template there. Under editor, advanced settings, for those using Spider, here's where we edit the template file. And this is just a template we save. Know that every single Python thing we write is going to have that guard statement. So let me zoom in. If the name of this file is main, again, that means that's the one we hit the run button on, or that's the one, this is the file we told the interpreter to start with. Then we're going to do something, but we don't know what that is. So in the template, I'm going to put pass. Right? If I don't put anything there, notice we get an error message. is that indentation rule in Python. We have to have it indented after that if block. But this is for the template. I don't know what to put there yet. Or sometimes with functions, we know what functions we want, and we'll go through and create that declaration line, but we're not ready to dig into the logic yet. Pass is just, that's the command for don't do anything. To placeholder. That's our standard placeholder. So I'll save that in the template. And yeah, you'll want to put this in every Python script you write. It's kind of like a main method in some of our other languages. That's the starting point. That's where we should start at. So you can see now when I open a new file, I automatically have that in template, which is really, really useful. Right. And any place we would be writing code has an option to set up templates, or your programmers. It's not hard to figure out how to make a template, right? A template is just a text file with some stuff already written in it. You don't know how to write a file, especially like in this case, there's more empty lines than anything else. Just write a bunch of lines with what your starting point is. Templates are easy to make. And there's some certain things that we know are going to be there every time. We don't need to start with a blank file. Go ahead and cut out some of that early work. Okay, so what do we want to do? I'm going to add a to-do comment at to-do. So what do we need for payroll?
How do we get that in VS Code?
In VS Code, I believe it's under the file menu. I haven't done it in like at least a year and a half.
What do we look for?
Template. Oh, somebody put something in the chat.
Snippets also?
Yes, snippets. Template in VS Code. Oh, snippets. Look for snippets. That's why I couldn't remember where it was. I was trying to think back, like graphically picture the menus. I couldn't remember seeing the template, but it's been at least a year and a half since I had VS Code installed on one of my machines, and I do factory resets all the time. I do factory resets more often than some people reboot their machines.
Will be added.
You can just check this link. I'll put it in the. Yeah, there should be an edit button. Oh, they got a nice little video. Yeah, VS Code has great tutorials. Actually, VS Code led to some of our best tutorials. Let me put this in the. Oh, you're not in the chat, are you?
No, I can't.
Okay. Yeah. You know all those YouTube tutorials, y'all have probably seen them, where they'll start doing something and then they'll talk about how great VS Code is for that. That's a requirement for people that work at Microsoft. Whenever they have downtime, they're supposed to make tutorials and talk about how great VS Code is for doing that particular thing. Which we don't show commercials for text editors, so that's what they came up with. Which is really kind of nice because then we have lots and lots and lots of tutorials made by some of the world's leading computer experts. And VS Code doesn't do anything we don't have in any text editor. Yeah, there's nothing really special about it. So if you ignore the VS Code, if you use VS Code, they'll show you where the buttons are. But if you ignore VS Code parts, then it's just great tutorials on just about everything. Made daily because there's a lot of downtime with Microsoft right now. So we want to do a payroll calculator. Just some quick pseudocode for the ideas here. Get name and hours. I guess we have to do rate. At this point, we need inputs for everything, right? Calculate overtime. Did I not already zoom in? I thought I zoomed in once. Doesn't seem to be zoomed in anymore. Calculate overtime. Or not. That's probably enough for our example. Oh, we might want taxes because we need. This example is to look at functions, overtime or not, and let's say 14% taxes. We'll just do a flat tax rate, but we're going to come back into a better tax a better payroll calculator later, one that would like read from a database, a more realistic payroll calculator. If we see web scrapers by then, we might actually check our IRS tax tables, and then even the tax would be accurate. But I think web scrapers are probably going to be near the end, and the odds and ends at the end. So just some, I guess I could format that a little bit better so we can see it, right? Like a bulleted list or something. Some pseudocode. In previous class, they may have spent a lot of time on pseudocode. Pseudocode is the messy part. That's where you collect your thoughts. Do I have an example? Which example do I have for it? So I'd have to dig find the one of the example softwares we're going to do this semester. I have some messy looking notes. They're on like a wadded up piece of paper. I was going to show you that one. That's when pseudocode gets useful, right? When your idea for the program is jotted down on a dirty napkin. It's not that clean, organized thing that somebody probably made a big deal out of in your SDEV 120 class. It's where we make a mess of our thoughts in order to get ready to put our idea together. All right, we want to do this all with functions because obviously that's what we're looking at this week. So we need some functions. I'm going to start defining them. So define get inputs. Sounds like a good name. And this is where our prompts, we're going to come back and do it. So in the end, the computer needs our code to be in a certain order, left to right, top to bottom, but that's probably not the order we think about it in. It is far more productive. This is just something I found over the years. Maybe you feel differently. I've found it's far more productive to bounce around that text file and put the code together in the order I think about it in than to try to think about it in advance and put it together in that order the computer needs it in. Because even after decades of programming, I still do not think in the same way that a computer thinks. So, yeah, and we have arrow keys in the mouse. We can put our cursor anywhere and just kind of bounce around in the order we think about it. So we need to get some inputs. Define check overtime. And when we do that, we'll need to pass a number in, won't we? What do we need? Oh, we need two numbers. We need to know the hours and the rate of pay for that. And we'll come back and work on the logic. So I'm just doing the method header right now. Just kind of stuffing them out, thinking about what methods I need. And this is one way I like to do it, kind of come through and think about it at different levels of logic. My view is what functions do we need as we put this together? We use those words interchangeably when talking, but remember for things like multiple choice questions, such as we would see on certification exams, that technicality methods are for object-oriented programming, functions are for procedural programming, and Python is only object-oriented, so we don't have functions in Python. But when we talk to other programmers, that's for the technical multiple choice questions and things. When we talk to other programmers, they're going to know exactly what we're talking about, say whichever word we say. So once we have overtime, I guess that would be calculate overtime pay. We can rename that later. Then we can deduct taxes. And for that, we need gross pay, right? And tax bracket. I wrote that in snake case, all lowercase letters with underscores. That's the recommended for Python. So when we get, I don't think we'll do it tonight, but if we were to hit the analysis button and look for refactoring suggestions, it would say our variable should be written in snake case. So I'm going to go ahead and do that. And we'll do the logic for it later. Then that'll return net pay. So then we just need to print it out, right? Define print check with net pay name. That all we need? Yeah. Kind of make it, we'll try to format it to look nice. I think that'll be enough for a payroll calculator, right? And then another one, I want to keep track of everything the software is doing, which is going to seem trivial in this case. We wouldn't need to really dig through, but something that all we can really do is talk about it in a classroom. In a classroom, right, we have to do things that fit in our time constraints. The absolute biggest is the semester project. And even that's something one person can probably do without a plan, right? That is not the state of modern software development, which means there's a big jump between graduation and that first job or internships. Internships are nice because you get a bit of a preview on it. Modern software development is, Facebook is currently working on a project with 32,000 programmers. And they're, when we at? We're February now. 16 months into one piece of software that 32,000 programmers are working on. That's modern software development. That's hard to even fathom in a classroom setting, right? We're used to like homework assignments and things that fit in a 4-hour class, but there's only one night that we're probably going to go to for 4 hours, and we'll take like 2 or 3 breaks that night. I'll let you know about in advance about that, just because we'd have to break in a really bad spot otherwise. But we might want to keep logs of what all the software is doing. So I'm going to create a logger function. I'll just call it logger. And it needs to log all these other things. So when it logs input, there's no parameters. When it logs the check overtime, which maybe that should probably be calculate pay. I'll call it gross. Calculate gross pay. Right, see, go back and forth, choosing names. This is how I like to build software. The pseudocode, the rough plan is very rough, and then make adjustments as layers of detail. Every pass gets more detailed and more detailed till we get those fine points. And by then we've thought it through fairly thoroughly. So we don't know how many parameters we need for logging a particular function. Some of our functions require 0 parameters and some of them require 2. And this is a really small piece of software, right? We're going to finish this thing before the break. So that's where those pointers come in, the args and cargs. We don't know what we're going to need at this point. That we're probably never even going to pay attention to what we need. We're just going to pass it around. So the pointers basically have the computer start pointing at different spots in RAM for whatever we need, keeping track of things, and then that passes it on so that the computer takes care of whatever our needs are for a particular situation. Now we can start building things. I'm going to start with that one that I was falling asleep and kept making silly mistakes on last week, that wrapper. So I'm going to come up to the top and get the imports ready. So from Func Tools, which is abbreviated, import wraps. Let's try this without all the typos this time. So let's go ahead and set up our logger, so that way as soon as we start debugging even our first function, we can check and make sure our logger works at the same time. So, and that'll make it a lot easier, because then instead of calling the logger function on whatever particular function we happen to be on, we can use it as an annotation. We'll just write the annotation at logger above the function call, above the function we want to log, and that the computer will handle the rest of it for us. We'll see that in a second. So to decorate, using a decorator, which is a special type of closure because that's one of a keyword that you're going to see on a multiple choice quiz at some point in your life, or might see at some point in your life. We don't have a midterm or final here, but there are certification exams and different interview questions that are very, very common for programmers. So you want to pay attention to those technical terms. So we need our inner function. Define logging, the one that actually does the logging. Don't think I need any parameters here because I'm just going to open a text file and write to that. So with open payroll.log, that sounds like a good name for it. In append mode, that way we keep our entire log as log. Sounds like a good name for a handler. Whoops. Scroll down a little, and so that's in the middle of the screen. And then we can just do
you put args and quads when we know there's going to be a parameter.
yes. Or yeah, when we're passing parameters. So I'll probably need to come back and pass that. Where's the one from the other day? Let me open that one. Argument delete. And some places we are passing the function like it's a variable, right? It's just a variable holding instructions, and other places we are actually running that function. So we have to pay attention to which one's which. So we do need args and quargs. We can call it whatever we want. The important thing is the 1 asterisk, 2 asterisks, whatever the plural of that word is. We need that when we go to run it because we have to pass the arguments at runtime. So that's our filler arguments. So we'll open this, and actually we do need those here, right? I was going to come back and fill them in, but this is the function we're running, so we need to know what those parameters are because we're going to log things like got the input, and we'll have a name. At that point we'll have name and rate of pay, and hours, name, hours, rate of pay. So those are the things we want to put in our log, right? So it's a lot easier with objects. I'll do for A in args. I was going to avoid passing list, so list would go into keyword arguments. Single values would go into arguments, and notice with all those method headers, we have single values all the way across the board. So it's thinking like that. That generic term is like, what might we have? So I'm just going to look through and print those out. Actually, we'll probably abbreviate that. I can do the arguments and keyword arguments. For now, let's just print what function it is. Print just ran the. Anybody know how to get the name of the function we're looking at? See people in the classroom thinking heavily. Anybody on Zoom call have thoughts? I was asking that as half a trick question because at this point I would accept Google it as an acceptable answer, right? Somebody tell me what to type in Google for this. How do we get the name of the function that is currently name of a function from our program? How do we get the name of the current function? I guess that's kind of what goes in there. How to get the name of the current function in Python. So Google finished it out for me, right? And not in purple. So just a hint, like sometimes when you start searching for that, change those around and look for those common searches that Google's already seen many, many times. We're like, oh, I think you're looking for this. lots of people ask about this because that's a good clue that it's something that's going to show up a lot when we're programming. So we want to import inspect and print inspect.stack. And according to that, we put it right in there. This is what I was looking for. Python doesn't have a featured access function. Bar or bar dot underscore name was the one I was thinking of. We try different things. Inspect dot current frame. That sounds a little bit better than that one way up here at the top, because this looks like it requires us to know which value of the stack we're currently on.
There's another solution on Geeks for Geeks.
Which one?
A different website, Geeks for Geeks.
What do they say?
They say that use function dot func underscore name.
That works too. That sounds like a much better introductory one. Yeah. Yeah, you all know the process of Google searching. I was going to go for that bars one. That inspect looked nice. So, yeah, so this is that. Okay. So notice GFG is the name of the function. Or here.
Oh, that. Yeah. Well, what it is.
Should I pass it?
The header versus method one, get function name and
Function underscore name.
Okay, yes. And we called ours was passed in as a parameter. We don't need to know what it's called. We called that parameter func. Abbreviated func. So func dot underscore give func name. That'll work. But there's lots of ways to do it, right? Excuse me. Yes. Just ran the func underscore name plus function. And that'll probably work for our log. And we can get to the keyword arguments the same way. Func underscore name is something built into that function. We can grab some other stuff. So we'll write that. Oh, whoops, not print. Log dot write. We're doing that to the file, not the console. Because then a line break. That'll work for our log. Just a basic one. Nothing too fancy, just the idea of a log for our class examples. We don't want to get bogged down in clutter. That's why I step back from that, actually using the args and bars thing. But we have access to them. This is a list. This is a list of values, and this is a list of lists. So that's how you would access them. So either a list with args is a list with single indexing, and quargs is a list with double indexing. And they always get passed through the same way. So you can just print them to the console to see what order they're coming through if you're not sure. But that's details that might ultimately just turn out being clutter on our example.
So we put args and quargs when we need to pass a parameter, but what if we are not going to pass a parameter and still we put those two values in? Would we get an error?
No, zero parameters is okay.
So even if we put those and we don't pass any parameters, there would be no error.
Exactly. So like our input function doesn't have any. So that would be okay.
We can just put it anyways.
Yeah. Yeah, that's the best one to be on the safe side. Put it anyways. So we write that, and then this is a closure, so we need to return something. I'm just going to return the number 1 because we're coming back from a logger, so we're not really doing anything. But it would be nice to have a number come back, that would give us a check, right? If it's a 1, we everything was successful. If it returns anything other than a 1, that means you got an error. Some sort of check like that. Maybe the word okay, right? If our return is complete, that probably looks a little bit cleaner on the line. If our return is complete, then we've successfully run our code. And then we need to return this is our return function, isn't it? Then return that function that we passed in with whatever parameters it has. So notice after we do this inner part, then we'll return this other one. Why doesn't it like that? Did I put that in the wrong order? Where's the example from the other day? Can you tell I don't do this very often? Do it every spring when I teach the class, and it doesn't show. It's quickly mentioned in the IB Online class. Whoops. Oh, wait. I should probably open it in the text editor. That way we can actually see it. Yeah, I might have had too much caffeine tonight. Overdid it coming back from the other one. And this is that thing that I mentioned the other day. Start keeping track of your own code to look back at for reference. So, oh, yeah, I put those in the wrong order. On the inside is where we return running that function. And then on the outside, we return the function. So there's our closure. So, what's that? And it is a confusing thing. So as you go through this, this is where we want to run the function. And this is where we want to get ready to run the function. Our closure, but it's not actually closed. Whoops. Log in. And then I'm going to hit escape so that the predictive text doesn't try to add things on again. So I got any parameters for that. Does that make sense? See how it says that generic example? We say what we just did. It'd be a useful debugging tool. What function did it run? What functions ran? What functions show up in the log before the program crashed? How far did it go? We can tell line by line what had happened. I'll give that a save because probably should have saved by now. We just wrote a bunch of code without saving. Go to the repository, put this in a new folder. I'll call it payroll because this is just going to be a one script type of software, but it's going to have a log with it too. So we need to probably want to keep that log around. I'll call this the same thing, payroll. I can't think of another name quick enough. So payroll.py. This one's going to seem really odd in the class. We're not doing anything. There's no errors marked. I'm going to hit run just to make sure there's not any runtime errors that we didn't see. Because your IDE is not intelligent. So the thing showing the red dots and the lines, it might not catch every error. And when you hit run, there'll be something that might crash. So even though there's nothing that's actually going to run yet, there's a more thorough check. Again, that's one that's not going to show up in Flash. But when you have like something where 500 people have been working on the same project for 9 months, in a much more complicated market scenario than we see on weekly homework assignments, that is more likely to happen. So those are useful tools, marking the errors and stuff. But as you progress further and further, those tools get worse because you're doing things more complicated than those tools can detect errors until it actually runs and crashes, or runs and then suddenly has to stop running. So usually tools get better as we progress, but the automatic marks on NIDEs on obvious errors, it actually gets worse as we progress further. Inputs is easy, right? Ever remember inputs from prerequisites if you've seen Python before? I got a whole bunch of guesses when I asked you all. I've seen Python before, so and I do this a little bit backwards. So this is another one I do backwards, almost type from the inside out. I need to get somebody's name. So the first thing I'm thinking of is the input. Input, I don't know. Let's do the 1940s mobster type prompt. Yeah, see the boss. He wants to hey, see, yeah, the stereotype 1940s mobster style prompt. Feel free to have fun with prompts in my class. I trust that you all know to do it, serious and polite and all that in formal situations, but we write a lot of prompts and homework assignments, so feel free to have fun with the prompts. Or throw some jokes in there. We'll grab that. So that's the first thing I thought of. Okay, now that we got that, we need to put it somewhere. So that's going to be the name. And inputs always come in as a string. A name should be a string, so we're good there. But that's the order my mind thinks about it in, which is definitely isn't left to right. The next one's even more, so we need to get the hours. Input. Let's do the cheerleader prompt this time. I'll add some comments so we keep track of those. So this is the 1940s gangster mobster prompt. Or probably 20s. Maybe 20s. I don't know when they talk like that. I've heard them talk like that in old movies. This time let's do the cheerleader prompt. Give me your hours. Feel free to have fun with the prompts. I write a lot of prompts. That's why I just change them up. Because the polite prompts get boring doing them over and over and over again. So there was a couple in the afternoon class and a couple in the evening class. And you can only politely ask them, please enter your name so many times. Before it's like, I gotta type something different. Okay, now I need to put that somewhere. So hours is a good name for it. Input is coming from the keyboard. That means it's a string. So we need to do the casting. Floater in. So we get it from the keyboard as a string. Do we need a floating point number or an integer? Yes. Because if you worked 23 and a half hours and your boss only paid you for 23, you'd be a little bit upset, right? A standard one in most keyboards, if you're not familiar with the shortcut, if you highlight something, so I'm going to hold shift and use the arrow to get around that. And then just the opening parenthesis, it'll put the closing parenthesis in. If we're typing from like inside out. We see how that kind of went in the inside out in a different order. But that's the way my mind thought about it. And that can be a little bit more productive over time. One more, we need the rate of pay. Input, what's money style? How much you make? Put some spaces next to these, after these prompts, so that there's room to type inside the string, not after it. I don't know why I did that. Going back to the home key to get to the end of that line. That's right. Is that this one's a little easier? Is rate a floating pointer in it?
You don't press in Mac.
What?
For home key.
What's that?
For home key, you know what we press in Mac.
Oh, command left. Command right is in. At least that's what it is on my Mac. Sometimes they change it, but it's been that on MacBooks for a while. Sorry, I gotta keep those in mind. Yeah, command left and right is home and in. Command up and down should be page up and page down. Some Macs might have a function key as well. If you have a function key, it might be function if that doesn't work.
No, command does work. I do that.
Okay. Float, yeah. Because it's money. So floating point number. And this time I'm gonna go to the end a little bit different. I'm gonna hold a shift and use the arrows like I did before. I'm gonna hold down control, and it is control on the Mac. And then push right. And notice how instead of going one character, it goes to the next logical stop, basically word by word.
It's an option. You can do that.
Oh, it is option?
Yeah.
I thought it was control. I haven't done that. Yes, it's option. I had to think about it. I had to think about it. It's like ring finger. Yeah, that's option, not control. At least, yeah, I know that. But you notice that out of order thing. Probably different than what you may not have seen that before, especially if you did one of the ones where like multitask grading and stuff. That's going away. We were in a meeting the other day. Yeah, you didn't know I'm the vice chair of this SDEV group statewide, and it's like we're taking money out. That might happen. Let's go back to grading my hand as soon as possible, like the second 8 weeks, because Cengage decided to update in the middle of something. It was already bad enough, and they updated and they messed one up. And this week's homework assignment and SDEV 140 is not possible. You have 2 different checks, and the same code will not work for both checks.
Done something in the get inputs function.
For
No, for the get inputs function, do we return something?
oh yes, we should. Good catch. Return all of them, right?
Yeah.
Name, hours, rate. So let's go give that a check. Always run a test every chance you get. Right? You don't want to write 100 lines of code and then try to debug it for the first time. Always fix one error at a time and run a check every chance you get. So we need to come down to our guard section so we can start checking code. So we're going to call the input method no parameters, but we need to put that somewhere. Name, hours, rate equals input. And then I guess we can just print those. I'll just copy them because they're already comma separated and print that for a check. Even if you only write 1 line of code, or actually, especially if you only write 1 line of code. Because if you've only written 1 line of code since the last check and a bug shows up, you know exactly where that bug came from. Run. Is it running? It seems to be in the middle of something. Why are my prompts not showing? So it looked like there was a bug. Let me stop that run.
I think you wrote inputs instead of get inputs.
It should be input.
Oh, go down.
Oh, yes. Thank you. Get input.
Inputs.
Yeah, you. Or-
Okay. Might have been easier just to change the one up top. Oh, wait, no, there's already something called input, isn't it? All right. All right. Boss wants to know name. Enter my name. Hours. Oh, no, just any number. And 12.34. Oh, looks like it came through. Okay. We've got our variables to work with and pass on to the next thing. So we can get rid of this echo. That's the term for when we just print stuff out to check. It's a useful debugging tool. Throw a bunch of echoes at random spots in your code, check what the values are as you pass through there. We also have debuggers to work with. So gross pay is next. that's an easy one, right? Tell me the logic for this. How do we calculate gross pay?
Hours times rate.
So gross equals hours times rate. But there is one little catch there, right? If you work 47 hours this week.
Hmm.
Yeah, so we want to check for overtime. The standard is when it passes 40. So if hours are bigger than 40, then we'll do this, but we need to multiply by 1.5. Hours times rate times 1.5.
That's not completely.
That's not right, is it? We gotta do something else first, right?
Rate equals, rate multiplied by 1.5.
There's one other step. So this part's okay. But this, if we work 47 hours, we only get overtime for 7 of those hours, right?
Hours minus 1.
Yeah. So we need the hours minus 40. Whoops. Not the shift key there. And all of this, and then our first 40 hours is just the regular rate of pay. I do shift tab to do indenting. Backspace also works, but if you didn't know, if you haven't seen that before, tab goes forward and shift tab goes backwards. Else, I should have just copied that formula the first time, shouldn't I? Gross equals hours times rate. And then we'll return gross. So we can check this now. Okay, ready for another check? Any questions, confusions, anything about that? Hopefully all looks familiar. Splitting it up into functions. Let's check this. Gross equals whatever that was called. Calculate gross. I'm choosing from the line this time, and it already. I was using names consistently, so it already knew to pass in hours and rate with no problem. We can probably do an easy check on this. So, oops, don't type there. Put the cursor over here. 10 hours at $10 per hour should give us 100. Oh, forgot to print that, but I'll check the variable explorer. Looks like we have 100 in gross, so that looks good. What about something with overtime? Run that again. B 45 hours at $10 per hour. We haven't done tax yet, so that should be an easy 400 plus 50. Oh no, more than 450. Because 400 for the first 40.
470.
Yeah. 400 plus 5 times 15, which is 75. Yeah. It's always good to have a place to do notes around. Scrap paper or something like that, just jot things down, or a calculator. You can check things like that. And that's behind the Zoom thumbnails. Let me remove those. 45 at $10 an hour should be 475. Yep. So it looks like it's calculating our numbers correctly, inputting things correctly. We just need to check the log. So let's check the logging. And that is a decorator. We set the log up as a decorator. So to log this, all we need to do is add logger. Nothing like it. Anybody have thoughts on what went wrong? So it didn't recognize the annotation for our decorator function. We put way down here.
Oh, because it's way down there.
Yes. Because the computer's going to start at the top of the file and read downward. So it needs to be in a certain order when we finish it. Probably not the order we think about it in. So I'm just going to cut and paste that back up top. Let's see what happens. Oh. Did I type that incorrectly? That was not the way I normally do it. We've seen underscore name before, right? No Python names things underscore name. I'm gonna give that a try. Where's that? Underscore name, underscore. See what happens. Oh, it didn't crash immediately, so that's might be a good sign. And say A 5. We got that. If we look over in our folder, we got a text file with a .log extension. Open it up, and it says we ran the inputs function. We ran. Looks like our log works. That's useful for debugging, right? And it's just an annotation. So that is a particular one that you could probably copy and paste over to someplace to keep around, and copy, and then paste that into any program you're working in, right? And if you need to keep a log for debug, maybe help debug and stuff, it's just an annotation to call it. Do you see the usefulness in decorators now? See how easy it is to create that logger? And and obviously expand that. Lots and lots of room for expansion on a log. Add color coding in. I opened that up in Notepad++, but it doesn't have colors, but most text editors have color. So add colors for the logs and things like that. And that'll get you started, and then you can create your logs just from an annotation. Makes it really, really easy. So we might as well, we know the annotation works, so let's go ahead and put that in everywhere. At logger. And now we'll keep accurate track of everything we do. And I'm going to delete the existing log because that was the first check, so we know it worked. Taxes. That should be fairly straightforward, right? Because I put up here in the pseudocode, let's just do 14% tax. Let's not go scrape the web and check irs.gov for whatever it would apply for that gross pay, because actually that involves checking all of their pay since the fiscal year began. Right? The things like Social Security, we only pay taxes on the first 112,000 we make. Then they stop taking Social Security out. And everybody in this room, you're in a software development program, you're heading towards a career where the lower end of the pay range is usually past that. They stop taking Social Security tax out. Which means you're in the highest tax bracket. So, that's why I like to dwell a little bit on taxes in these classes, because everybody in the SDEV classes, you're going up, you're heading to someplace in those high tax brackets, and they're bad enough when making working in restaurants and stuff and seeing how much the tax man wants out of the paychecks there. And it's a much bigger percentage when you get out there software development. But we have our gross and our tax bracket. We're going to pass that in because realistically that would be different for every single person, and it's different every single week, and a very, very complicated thing. Taxes are 2 courses here on no, 3 courses. You do payroll, tax accounting, then you can do payroll accounting, and then the advanced tax accounting. Do you have a question, Jaden? Oh, just stretching. Okay. Yeah. So taxes are it's 3 classes to learn taxes. But yeah, so we're just gonna do easy taxes. So deduction equals gross times tax bracket, and net is going to be gross minus deduction. We could do that in one line pretty easily, but I always like to say it like this: think about computers doing ones and zeros. What the machine itself is doing is it's doing something small, or it's not doing something small. So we can do fancy lines of code, but really all that does is make it harder to debug. Lots of small, simple lines of code are easy to debug, and the code here isn't really what's running. Need me to zoom in on that? Are you having trouble with section J, Jamie?
Yeah, I'm reading first, like,
Here, let me look at what message. Yeah, for those on Zoom call in here, feel free to stop me. I'm doing this so you can follow along. I could type this way quicker than this. So okay, so line inputs, we get those, and if run it so I can see exactly where it crashes. So we're missing it says missing a colon. I see a colon on that line. If 36. You see that? There's a bunch of messages up top, and I see a colon there, so that can't be the problem. Runs it. Says it automatically interrupted. Line 36, there is a colon there, a colon there. Oh, there's an extra equal sign. On line 38, that one of times. And that right there is part of the reason programmers work in teams. We don't, a second set of eyes is useful. I've been waiting for a good example of that to show up. So yes, please stop me anytime you're something's going wrong, because I'm doing this so you all can follow along the example, right? It's we learn by doing. So the best example of it is we can all see our nose all the time. We just ignore it. That's why there is a certain age when that got your nose joke is fun. Because it happens at a very specific age that eventually our brains right around the same time all finally realize, oh, I don't need to pay attention to this thing. It's really an instinct to avoid sensory overload. We don't pay attention to most of this stuff, right? Like standing up here in front of the computer lab, I've seen the backs of all these computers. There's a good chance that my brain quit paying attention to that 45 minutes ago, if not earlier, because it's not changing. There's no need to continually process that information. Kind of like compression. The reasons for compression in computers. That does happen. And when we're writing code, our brain knows what is supposed to be there. So it will just completely ignore our eyes. Our eyes will look at the page and there'll be a typo, and we will actually see the correct code because our brain already thinks it doesn't need to look, it doesn't need to listen to our eyes. It's like, oh, I just wrote that code. I know exactly what it is. So we will not see typos. second set of eyes is useful for that, but sometimes the second set of eyes will miss it too. Because again, if you know what code is supposed to be there, your brain might just fall back on that avoid sensory overload instinct and completely ignore whatever is actually on the page. Over the years, what I've found is if you know which line the problem is on and you don't see the problem, delete that line and retype it. And 99% of the time that fixes it. Which means the error was there and which our brain decided to ignore our eyes and just see what was supposed to be there instead of what was actually there. That does actually happen. So part of the reason programmers work in teams, then there's multiple sets of eyes looking at the code. Did that work, Jaden? It is working now? Okay, awesome. So we're returned on net pay, and that's 7:15. I was hoping to get finished by 7 before then, but we still got one more to write, and we need to check this, but that's been an hour and 15 minutes. That's a long time to stare at a screen without looking away, right? So let's take 10 minutes and then finish this up. We're kind of in a test this function, check the next one, and then we'll get into the next thing because I've heard multiple versions of the rules, 20, 20, 20. Every 20 minutes, make sure you look at something 20 feet away for 20 seconds because screens are bad for your eyes. I won't make a big deal out of this. I do it in every single class. I'm teaching people how to sit at a desk and use a computer, which is one of the absolute worst possible things you can do to the human body. So at least once in every class, I talk about ergonomics, the better tools, especially I'm on a laptop. Everybody in the class is on a laptop. This is a terrible shape. That does not fit our hands. That is a terrible, terrible thing to do to our fingers. If you're heading into coding, we'll look at better keywords and stuff. So we'll make a big deal about that, but definitely need to take a break and get away from the screen for 10 minutes. My laptop says 7:16, so we'll get back to it at 7:26. See y'all in just a moment. That's not good, right? There it goes.